Greetings, all you out there in GameMaker studio land. This is the Wizard here bringing you a short little video on how to use my new extension, TweenDreams, available now on the GameMaker Marketplace beta. So once you've got it ready to go, you can just add it to a project here. So we're going to just start with a brand new project. Project 3. First thing we'll do is grab it from the marketplace. My library is where we'll go. Gonna click add to project after it's downloaded. It's gonna take a hot second. Resources. So included are a very large number of scripts, as you can see. A little PDF guide. An example project that includes a lot of the sort of sample uses for how you would use a lot of these things. We just want the scripts right now, so we're going to grab those. Should take a second to import. Very cool. They're over here now. We hit OK. I'm going to close this. See all those scripts pop up. As I mentioned, there are quite a few of them. We'll go over the basics. A lot of these are mostly for extended use, and many of them are internal scripts that you will never need to call yourself. They're just called inside of the other scripts. So that's how the organization works basically. We've got the built-in variables, custom variables, internal scripts, which you really don't need to mess with those unless there's stuff you want to delete. In which case, depending on which scripts you end up using in your project, you can simply delete the folder for the things that you do not need. So if you don't use custom, you can go ahead and delete needed for custom. If you don't use the built-in, you can go ahead and delete needed for built-in. You're basically going to need this one no matter what. This one just contains all of the ease formulas, which are inside of here, in a big crazy tabbed thing. And of course we also have twerp, which is like lerp, but for using these easing functions. So this can be called not step-by-step, but sort of anytime. And we'll maybe talk a little bit about that. The easiest thing to do here first is just make a parent object. Pretty straightforward. In our create event, we're just going to add one of our initialization scripts. So this is going to be tween built-in init. You'll notice that all the scripts will have the arguments listed on the bottom here. Both the built-in and the custom, which are the ones that can be run automatically, require an initialization script, the init. And they take the argument of 0 for millisecond timing, 1 for frame or step-based timing, and 2 for frame rate adjusted steps. That would be if your frame rate drops the following step. It will add more than one step potentially, or 1.4 steps or whatever to catch up, basically. For our purposes, we're just going to go ahead and use the step-based. It's going to hit 1. So that's the one of the essential scripts, number 1. There are 3 of them. The next one we need, which we'll go ahead and put in the begin step. You can also put this just in the step event, or call it as needed. You might want to use it inside of an alarm that runs every step when you have these things that are active. It shouldn't really make a big difference performance-wise. And for the built-in, the script we're going to use here is going to be tween built-in step. This script will increase the time. It'll move the time forward 1 step for each tween that's running, for each animation, essentially. And we'll also assign the new value. Cool. We need one last thing on here. We'll put this into the destroy event. The easiest place to put it, this is our cleanup. These scripts use a DS list, which you will never need to access directly, but it does get created at the beginning in this initialize script, so we need to get rid of it at some point. So that's what cleanup is for. So we just put that under the destroy event, and you just need to make sure that if you're changing rooms or whatever else, basically when we're no longer using this object, that we run that event to get rid of it. You could just put this straight into the room end. It's really kind of up to you how you want to handle the memory management, but I typically do it this way just because if this is going to be an object that gets destroyed at any point while it's in the room, it'll just run the cleanup, or when we switch to the next room, we'll get rid of it. If you want to have, you can certainly do this with a persistent object. It works fine for that. You just don't want to run the initialize more than once, and you would not want to do the destroy on room end. You would just want to hang on to this, and then probably do a game end cleanup to get rid of the DS list. It's less important once the game stops running, but still worth doing your due diligence on. Okay, great. So those are the 3 basic scripts that we need to get this up and running. We're going to add a new object here. This is going to be our explosion. So we're just going to make a little sort of explosion effect with the tween. We're going to set our parents to the tweenable. We're going to hit OK so we get the fresh name on there. Very good. We're going to create a create event. I like to use drag and drop for this. First, we just want to call the inherited event. And when this is created, what we're going to have it do... where did it go? Oop, there we go. We're going to have it change scale, which is one of the built-in operations that we can do. So we're going to have it scale up. Scale up. And this will just be tween image. We can do scale, which will do both. We can do X scale, which will just scale the X, and Y scale, which will just scale the Y. We're just going to use scale. This will basically create 2 animations, one for the X and one for the Y, that will just be synced up. We're going to start it at 1 and end it at 4. Again, we've got all of the arguments down here listed. The duration is going to be 60 frames. We're going to run at 30 frames per second, so it'll take 2 seconds. The type for X scale and type for Y scale, this is actually the script that we want to use. All of the easing functions, the equations, those scripts start with just ease. So if we type ease, we can see all the different options. We're just going to start with none for right now to show you what it would be like without any type of, with just a linear interpolation, basically, a linear ease. Notice too that since we're including these scripts as arguments, we do not want to include the, we don't want to have the arguments for the script or the parentheses. We just want the name of the script, because that's actually going to be passed in as an argument. We don't want the result. We just want the actual reference to the script. And that's how it will work for all of the types. It's just the script name that we want to use. And again, they all start with ease, so it's easy to find them in the autocomplete. Ease, and they're organized by the type of ease, and then whether it's an in, out, or out, in, which are available for all of the different options. So there's 10 different types of easing with 4 different sort of methods. Cool. Then we also have a random delay in frames. This is actually based on just the time. So if you're using millisecond timing, 1 will be 1 millisecond, etc. What this will do, though, is the tween will not start moving until it reaches a certain number, and it picks that randomly. So that if you have a bunch happening at once, you can set a random number, give them all the same random value, and you'll get a little staggered effect to it. There is a way to sync them up if you want. and to set a manual delay, because once the tween has been started, we can access all of its variables. So once we've run this script here, this function, to start it, so all of the ones that will start it will just be tween, and then whatever the variable that we're doing for the built-ins, we can then access all of its internal arguments. For scale, you can use either the X scale or the Y scale to get the beginning, ending, types, whatever, because they're all the same. So we can get the time. If we had a delay on this, we could get the time for the X scale, store that as a variable, and then use that in the next one with a set time after we set it. So let's say we have 2 of these. This is just an example here. So let's say we do image angle, same thing, but we have one of these as random, the image scale. We could pull the image scale X time, and then we could use tween image angle set time to have them be the same at the same time. So that'll sync up the delays. You can also just set the delay by setting a negative value here. -6 will take 6 frames before it starts. If you set this to a positive value, it'll start that many steps into the tween. And we can use this to sync them up or do various things. Or if you just need to check how many frames are left, all those options are available for every single variable that goes in. So the duration, the end event, which we did not include here, the type, which again is that script, and the beginning and ending values, which are the first 2. These scripts are designed so that it will always, on the first step, be this value, and always on the final step be this value, so you don't have to worry about checking for... You're going to know what it is at the end, as long as it runs to completion. The optional arguments here, which are in the square brackets, are an event to perform on completion, and then the event number. These are the same arguments you would provide to the event perform function that's built in. So if you're having some trouble with having your events working, the first thing to check is that you're actually giving it the right arguments here, which the help on this is very good. There's a lot of detailed information here about what you need to put in. The most common mistake that I've run into is that I don't use EV other for like the user events. I try to just do like EV user as the first argument, but for all of these it needs to be EV other first, EV user after that. And the example project has a bunch of those, so you can see how that works in the example project pretty easily. For this one, we're not going to set an end event for right now. We're just going to have it scale up. It'll go from 1 to 4 over 60 frames with no easing. And that's it. That's all it will do. We could here too, actually, if we wanted. Let's do it this way, just to sort of show off this function. Let's do EV. It's going to be EV other. EV, I believe it's room end. So we're going to run the room end event that's in our parent here, which will destroy it. So when it finishes, it'll get destroyed by running the room end event. Boom. Now we just need a room, and we need a way to spawn these, because it'll be more fun to actually click them and have it show up in the room. So this is going to be obj spawner. It's not going to be visible, and this is just going to be a just a key click thing. Nope, not what we want. We're just going to use the event here. Global mouse left. Instance create. So we're going to create the explosion object at the XY that we click. Throw that in the room. Spawner. And then of course we need just some crap here, so we'll do this without much fanfare. It's worth noting that when you're using rotation, image angle, or image scale, if you get unexpected, if it looks different than what you expected, just be sure that, remember that the point of origin is what the rotation and scaling will occur around. So if you want something to spin in place, you need to have it as a centered origin. Okay. Oh, and we need to assign this. Very good. Now when we run, anywhere we click, we should be able to create the explosion. As long as I don't have any syntax problems. Oh, I have it setting at the XY and not mouse XY. Okay. Oop. Let's go over here. Plus Y. Oh, and here's an important lesson that I'm remembering now. Having it destroyed at the end, it gets destroyed in the middle of an event, and the event will finish. So if we actually want to destroy something at the end of a tween, because it will continue to run through all the other existing tweens, even if there aren't any others, it'll continue looking. Things will get screwy because we'll destroy that list before we're done looking through it. So just as a general rule of thumb, what you want to do is instead set an alarm. So we can actually do a user event here and just have it happen in the next frame. It's a useful lesson. Oh, this is the user. So we can do instance destroy. Well, let's just do the drag and drop for that. Okay. We make our user event, which will just set the alarm. All right. Let's also turn off the interpolate. There we go. Takes a little time. So that's without any easing equation on there. So if we go back here and we give this some different stuff, we can have it look much better. We're going to do a bounce in for the X and a bounce out for the Y. This is over the same period of time. Very cool. We can add a... we're getting multiple because this is not... should be pressed. We could easily throw in over here. Let's say we want to have it rotate now, like we were talking before. We can do a rotation, so tween image angle. We want it to go from 0, so this is in degrees. So this is the same thing as setting image angle. Image scale is the same as setting image X scale and image Y scale. So if you're unsure of what some of these built-in functions are going to do, just look up the built-in variable that corresponds. So like direction, if you need to know what that does and all that, it's all in the help file. So these just change those values over time. So we're going to go from 0 to 360, which will be a full rotation. We'll We'll give it 30 so it happens over half the amount of time. The type will be, let's do just a cubic in, no delay, no event. In order to ensure, if we had, let's say, if the event we called here was actually calling another tween, which is easy to do, if we wanted to create like a loop where it would go from 1 to 4 and then go from 4 to 1, back and forth, it's important that you have that event, any event that's going to be called, that's going to be setting new tweens. If you want things to actually reach their final value, you need to make sure that that's the one that's called first. They're going to go in the order that we add them, which in most situations will not matter. Basically, the only situation where that comes up is if you need to if you have it calling the same function, because these will just overwrite. So if we call image scale again, it just overwrites what we set for this, and then that new one will run. So when you're running one, you're going to start one that's the same. You don't have to worry about stopping it unless you want the end event to be executed. There are scripts included for stopping, getting the state, for pausing, resuming, all that's included. So if you need to check whether one is running, whether it's paused, all that can be done pretty easily. So now we've got a little rotation. It rotates pretty quick because it's only in the first half. You can see it gets to where it's going pretty quick. Boom. So we can make this take longer. This will do basically the same thing. These functions are really great for getting a little bit of a more interesting look to these types of changes over time. Included also is a function called twerp, which is like lerp, the linear interpolation, but we can use the easing function instead. So for example, things like volume control, if you don't want it to be linear, which is how GameMaker sets their volume, you can first run it through the twerp function to get exponential scaling or quartic scaling with the ease in with the ease like quartic in, and that'll actually so when you increase your volume slider, perceived volume will be better because that's how our ears work. Things like that, it can be used for that. It can be used for RPG stat systems, for damage calculations and things, instead of just anywhere where you would want to use like a curve to calculate something. The easing functions are just that, curves. So that's the basics there on how to use it and getting it first set up. The custom is essentially the same. The only difference on custom is that where we're running on parent tween here, where we're running built-in step, this just goes through and updates all of the built-ins that are running. For custom, we have tween custom step and tween custom step color. And these take an index and a current value. So when we start a custom tween, it's the same thing as starting the others. It's tween custom. We assign it an index. This is something that we'll use in the step event to reference it, basically. And then it has the same types of arguments as all the other tween functions do. So that's the only additional one. And then when we call it, we need to include that so that it knows which one we're looking for. And then we need to include a current value so that if it's not running, that's the value it's set to. This is so that you don't have to check to see whether or not it's running. You can just say like tweened value, right, equals the custom step, because this will return the value. And then you can just put it in here. So that if, for example, if this starts at 0 when we initialize, when the tween's not running, it'll just be whatever the last value was. It won't change. This way we don't have to check for the status or anything before running it. Color works the same way, except that it returns a color. Tween custom, you don't need to specify whether it's a color or not. If you provide a color as the start and end value, then it will. Then you'll need to use step color to return that. These use the color ones along with the image blend tween, which works just like image blend. They use the color merge built-in function, or merge color, I think it's called, which is kind of like lerp, but for colors. But the thing about merge colors, it does not extrapolate. So if you use the elastic, or the, there's one more, back, elastic, it might just be those two that extrapolate beyond the values that you input for the start and end values. These are hard locked to give you a number between 0 and 1 as far as what it returns, so you won't get weird flashing with those, but they look less useful. Hard to explain that, but it's worth checking out. What I'll show you next here real quick before we wrap up is just the example, just the demo basically that I have thrown up online there. If you want to check that out, let's see if this will keep capturing on full screen. Yep. Okay. Just set that here really fast. Demo. There it is. Okay. So this is the demo that's included. This shows off basically everything that we can do here. So here's some little blocks that have some tweening when they move in. We've got all of the different tweening functions rendered as a curve, which you can go through and sort of see how those look. So there's 40 different options, and of course just the none, which is just a linear. So if you want to have some idea of sort of how these will deal with scaling values, this is a good thing to check out. There's some examples of using the custom, which we're using to control the width of the lines and the rotation, various other things on this example. This one just has like a loop. It has some things with image, with the sort of motion trails, which are being scaled using twerp. So that is actually dependent on the X scale, so you can see how the motion trail, the way it scales, is different. Along with the color scaling here, and you can sort of turn these things on and off and check them out. The block thing, I can show you briefly here. We can just spawn these rows of blocks. They will tween in and rotate. When we click them, I'll do some stuff. So these are just, 2-frame animations for the actual sprites, using tweening to kind of make the motion just look much better. And then this is an example of the delay function. So all of these have the same delay. They're all spawned at the same time, but the delay is randomized, so we get a nice little staggered effect when they come in. These scripts are also, well, the example has a lot of sample usage as far as figuring out having durations that are based on time, having durations that are based on like the speed, all that fun stuff. So that all looks good. Please check that out. Thanks for tuning, and take care.